Thank you. Excellent, thank you. How do we follow up a presentation like that? I feel so much pressure now to be funny and smart. Okay, so my name is Julia Fransson, and I'm here to talk to you about what we do at Builder and how we're working towards the robotic future of construction. And I want to start off just to set the scene by showing this picture. So this is a modern manufacturing industry today. You meet advanced digital technology, and that has really spurred, it's totally changed the way they do things and has revolutionized productivity. If you want to go onto a construction site, which is really industrial production of homes and commercial buildings and schools, this is what you meet. Fantastically skilled workers, but the tools they have are handheld, and we've heard from several speakers today what's been going on with productivity in this industry. And we want to change that. So we want to take this proven and existing industrial robotic technology that's been used in other industries and implement it on the construction site. And this is what we're developing. This is Walter. Walter is our robotic drywall installation system. And when we thought about all the things you can automate on the construction site, we chose drywall for two main reasons. Firstly, it's a very common task. Drywall is a standardized material, and it clads the interior of walls all around the globe. There's a massive amount of drywall that is being installed. Secondly, drywalling is a task that is repetitive, monotonous, and very heavy. These boards weigh 20 kilos and up, and the only reason they weigh that little is because of ergonomic requirements for the workers. Otherwise, we would be using even bigger boards. So it's a task that's really not well adapted for a human, but it's a perfect task for a robot. This thing is made for lifting heavy things day in and day out. And our goal with this system is partly to reduce work-related injuries resulting from this repetitive heavy lifting, but also to improve productivity in the construction industry. And we do that by shortening cycle times, allowing continuous processing, and importantly, unlocking the night shift. Because this is what it looks like on a lot of construction sites all around the world during the night. I mean, we build these fantastic temporary production facilities, and then we just let them stand still 2/3 of the day. That feels like a waste in an industry where we have productivity problems. So our goal is to release the robots onto the construction site during the night, have them do the volume work, all the straight walls, the simple tasks, the bulk of the work. And then we let the human workers come in during the daytime and do the more skilled tasks, where you need to cut boards a lot, the tricky corners, or where you need to cut boards to fit around windows or doors. So really having a workforce that complements each other, that is both strong and relentless, but also smart. And I just need to get some water. I left it on the wrong side of the stage. And then we started thinking, so how do we get this advanced technology out onto the construction site? Because construction is, as we've already heard several times today, it's a quite conservative industry, and for good reasons. It's an industry where you usually work in projects that are always tight on time, always tight on budget, and there's low incentive to kind of go, yes, I'm going to invest in this really, really expensive machinery that is advanced and highly technical. It might help me. That's a really tough sell, we thought. So instead of selling robots, we're going to sell the service of drywall installation. Drywall as a service, everything should be as a service nowadays. This sounds very cool, but of course this is business as usual. If you look at large-scale construction projects, most construction projects, a lot of the specialized work is subcontracted to specialized contractors. So our goal is to integrate seamlessly into the value chain, providing the same service as any other drywall contractor, but and the same quality, but be able to do it partly with a robot. That will enable our customers, so the construction companies, to get the benefits of this digital technology, but they don't have to take the technical risk. They don't have to make the large investment, and they don't have to train their workers in using it. And it's also a positive thing for us because we can really access the market a lot faster because we're developing a project for our own team and not for any person that can just press a button and have it start. 2/3 of the cost of a drywall arises on the work site. So it is pretty much only labor cost. So we know that we're targeting the real, where the real costs are. And we believe that the time to introduce a system like this is now. There are strong drivers, both market trends and technological trends in both the construction industry and in the robotics industry that really allow for this to happen now. Firstly, we have the increased use and introduction of BIM models and VDC work. The models are becoming increasingly detailed and accurate, which means that we can enable our robots to work based on them. So it's already digitized information that the robot can use as an input. The robot isn't great at looking at a blueprint and understanding what's going on. It needs digital input. So that's a great enabler. We also have the strive towards working lean. And the big reason for that is to increase productivity, to work smarter, not necessarily harder or longer. And the robot is really an excellent means to that end. But then we also have what's happening on the industrial robotics side. Because there are good reasons why there aren't lots of robots already roaming around on construction sites today. Up until a few years ago, robots have been excellent at standing in. They've been bolted down on these factory floors. They've been doing their thing in their safe, closed-off cell. But they've had no idea what's going on around them. Today, there have been fantastic advances both in mobility, so automated navigation, but also in sensor systems, machine vision systems that allow machines to talk to each other, to understand their environment, and also to, to understand what's going on around them. And the construction site is a place that changes every day, so it's a quite complex environment. But I mean, if we can have cars in real time, in real traffic, they're allowed to drive around and can handle that situation, I think that we can make a machine that can handle a construction site. It shouldn't be impossible. And we'll skip that one. So this is what we're trying to develop. And normally when I have this presentation, I usually talk about our system on this picture. But now, during the last year, my fantastic team has been working really, really hard at developing the first full-scale prototype of the system. We've been doing that in collaboration with ABB, which is a global robotic manufacturer, and NCC. So we've had both the robotic expertise, but also the construction industry showing us what needs to be done, making sure that the robot fills the requirements to be able to work on a real construction site. And so instead of talking about a system showing this picture, let me show you the real thing. So this is where we're at today. So this is a mobile system with a robotic arm that can lift and secure drywall boards to studs. What we have is at the bottom you see a mobile platform. It has wheels that allows it to move in any direction. And it has a laser scanner. The laser scanner does two things. Firstly, it navigates. So it builds a map of the environment so the robot can actually see where it is, which means that even if it has the BIM model as its blueprint, it can deal with someone having put a ladder in the way. So I can't go here, I have to walk around this thing because there's actually something here. And it's also a safety measure. The laser scanner will sense if there's a human in the workspace, and if it's far away, it'll slow down. If it's really close, the whole system will stop. So we don't want to hurt anyone with this. So that the laser scanner does two things. You also see at the bottom here there are batteries. So this entire system is battery-driven, which really enables it to be autonomous. Otherwise, you have to go plug it in every time it changes the room, which wouldn't work. Up top, we have this fantastic robotic arm made by ABB. This is an IRB 4600. It can lift 60 kilos. It's super strong. It's unfortunately really large right now, but that's another thing that's going on in the robotics industry, that they're looking at developing lighter robots. At the end of the arm, you see this gripping tool. It lifts boards using vacuum, which is the same way you lift boards in the gypsum manufacturing industry today, so we know that works. And then there's an industrial screwdriver up top. So this is a screwdriver that's made for sitting on a robot. We thought first that we could put a normal, these handheld devices that the carpenters use, but they're not really reliable enough. They require you to, now and again, change the bands and jiggle the screws so that they're not stuck. This thing is made for robots, so it's made, you shouldn't have to fiddle with it. And then we have some accessories that enable the entire system to work. So control cabinets and battery management systems and compressors and stuff. And now I want to show you a video of this working. So our first functioning prototype. And this is a video we've only shown to our like really, really close collaborators, like 3 people so far. So this is really a world premiere of the system. And here it is. So here you see the robot it's in position, so close to the studs. This is in our lab in Eskilstuna, so that's why there's not a full construction site around it. So it lifts the board. This is super stable. We've lifted, this is a normal size 260 board, I think, but we've also test lifted 3-meter boards, and it's also super stable. I told you it's battery driven, and I can guarantee it is, but you see lots of cords running to it. Let me explain that. That is because right now the robot we have in this lab had a stationary controller, but we have a new robot now with a portable one. But there you see it. So it attached the first screw, and then released the vacuum. And after that, it can move the entire gripper tool around and place the rest of the screws. Right now, it's only going to place a few up top and a few on the bottom, but you can imagine it actually screwing the whole board. This is a lab setting. There are people really close by, so it's not moving as fast as it could. So here you can see the screwing process up close. So the screws are fed using pressured air up to the screwdriver attachment. And then it keeps screwing. And then we'll also, it's another part of the movie where it shows it actually, how it moves. So this is this system is quite heavy right now, but it moves really smoothly in all directions, which enable us even to be able to move around even in quite small environments on the construction site. So this is what we've been working with up until now. Oh, thank you. Yeah. We think it's pretty cool, and we showed this for ABB, and they were like, "Is that our big robot? Isn't that the small robot?" And we're like, "No, that's your big robot." So putting big robots on mobile platforms like this, it's not done. This is one of the first examples. We haven't seen anyone else do it with this size of robot. So we're very happy about that. But right now, in a month's time, this will be tested on a real construction site. So that's the next goal, to have it in a real-life environment. And we plan on keeping doing that for the next years, trying it out on different construction sites and getting it into real-life projects. And I just want to end off by saying that going into this, you have so many people saying, like, "Oh, this industry is so conservative. How are you going to be able to get this new kind of technology into this industry?" But we've been met by so much positivity and curiosity, and companies calling us saying, "When can we test this? This is so interesting." So, and that together with everything that all the other presentations we've heard today, that really makes me believe that we are on the verge of the real digital era in construction now. The industry is ready, and we're really excited to be part of it together with you. Thank you.